Dear children, today we are going to study about the concept potential energy. So what do you mean by the potential energy? It is the energy stored in a body or a system by virtue of its position or by its configuration. So with some examples we can see what is the potential energy due to its position or due to its configuration. So the first one, due to its position. So a body lying on the roof of a building has some potential energy. Okay. When allowed to fall down, it moves with some kinetic energy. So here the potential energy is changed into kinetic energy. So in this case, due to its position, the body acquires the potential energy. Then the second case, due to the configuration, what is the potential energy? So a stretched bow. Okay, a stretched bow possesses potential energy. So as soon as the bow is released, it shoots the arrow into forward direction with a large velocity. So what happens here? The stretched bow possesses potential energy. So the potential energy of this stretched bow gets converted into kinetic energy. So the arrow moves in the forward direction. Clear? So here the potential energy is due to its configuration, due to its shape. Clear? Then what are the types of potential energy? Okay, so you want to go through this, the potential energy due to its configuration. Then types of potential energy. The first one, gravitational potential energy. So it is the energy possessed by the body by virtue of its position above the surface of the earth. That is the gravitational potential energy. Energy possessed by the body by virtue of its position above the surface of the earth. That is the gravitational potential energy. Then the second one, elastic potential energy, that we can see it in the next content. So I will give you the definition. It is the energy, it is the potential energy associated with the compression or extension of the elastic spring. When the spring is compressed or extended, then the energy possessed by the spring, that is known as the elastic potential energy. Clear? Then the third one, electrostatic potential energy. It is the energy due to the interaction between two electric charges. That is the electrostatic potential energy. Okay, interaction between two electric charges. That is the electrostatic potential energy. Clear? Expression for gravitational potential energy. Okay. So what is the gravitational potential energy? It is the energy possessed by the body by virtue of its position above the surface of the earth. So here we are considering a body of mass m lying on the surface of the earth. Then g be the acceleration due to gravity at this place. So you have to lift the body through a height h. So this h is very much less than radius of the earth. So the value of g can be taken to be a constant. So you have to lift the body through a height h. Then what is the force needed to lift the body? So it is equal to the weight of the body. So we can write the force needed to lift the body through a height h, that is equal to the weight of the body. So what is the weight of the body? It is mg. Clear? It is equal to mg. So to lift the body through a height, you have to do some work. So what is the work done on the body in rising the height h? So what is the formula of work done? That is equal to force into distance. So what is the force here? That is the mg. And what is the distance moved by the body? It is equal to the h. So we can write force into the distance. So that is equal to mgh. So this work done is against the gravitational force. Okay, so this work done, that is gravitational force is acting downwards, so you have to do the work against this gravitational force. So this work done against the gravitational force is stored as the gravitational potential energy, noted as U. Okay, U equal to gravitational potential energy, U equal to mgh. So this is the expression for the gravitational potential energy. Clear? So at the surface of the earth, what is the gravitational potential energy? So at the surface of the earth, this height h, that is equal to 0. At the surface, h equal to 0. So gravitational potential energy is equal to 0. Clear? At the surface of the earth, h equal to 0. So gravitational potential energy equal to 0. Clear? Conservative force. So what do you mean by this conservative force? A force is conservative if the work done by the force in displacing a particle from one point to another is independent of the path followed by the particle and depends only on the endpoints. Okay, that is, a force is said to be conservative when if the work done by the force in displacing the particle is independent of the path, but it depends on only on the endpoints. So we can see one example. How can we say the gravitational force is a conservative force? So with one activity, with one example, we can prove that gravitational force is a conservative force. So here, suppose a body of mass m is raised to a height h vertically upwards from point A to point B. So what is the work done against gravity here? That is equal to, you know, what is the expression? That is equal to mgh, that is force into the displacement. Okay, so that is equal to mgh. So mg, that is the weight of the body, and h is the distance moved by the body. So work done against gravity, that is equal to mgh. So this same body is moving from A to B along this path. Clear? The same body is taken from the point A to B along the path AC, D, E, B. So here what are the paths here? AC, then CD, then DE and EB. So you know that in the horizontal path CD and EB, the force of gravity is perpendicular to the displacement. So force of gravity is acting downwards and the displacement is in this direction. Here also force of gravity is acting downwards and displacement is perpendicular to the force of gravity. So what happens there? So in this case, that is along the CD and along the EB, the work done is 0. So what is the total work done in moving the body from A to B? So we can write the total work done, W equal to, okay, W equal to work done along the path AC plus work done along the path CD plus work done along the path ED plus work done along the path EB. So what is the work done along the path AC? It is equal to the force into distance, that is mg into AC, plus what is the work done along the path CD? That is equal to 0, plus what is the work done along the path ED? It is same as this, the work done along the path AC. Okay, that is mg into E DE. Okay, we can write DE. So what is the work done along the path EB? That is equal to 0. So what is the total work done here? That is mg, okay, mg into AC, okay, mg into AC plus DE. So what is this AC plus DE? So this AC plus DE, that is equal to this total height or the total displacement moved by the body, that is AC then starting from here, that is the dE. So this is the total displacement moved by the body. So that is equal to mg into AC plus dE, that is a h. So in both the cases, W equal to mgh. This work done is stored in the form of gravitational potential energy. So what do you understand from these two cases? Here the work done in moving the body against gravity is independent of the path. Okay, only it depends on the final positions. Clear? The work done in moving the body against gravity is independent of the path. Only it depends on the final positions. So we can say that gravitational force is a conservative force. Clear? We can also say the force is a conservative if the work done by the force in moving a particle around any closed path is zero. That case also we can say that the force is conservative. So look at this example here. When the ball, so suppose a ball moving in the upward direction. So here the work done is against the gravitational force. So what is the work done? Here the work done is negative. Then the kinetic energy decreases when the ball moves in the forward direction. Then the kinetic energy decreases, and when it rises to the height, it has the maximum potential energy. Then what happens? The ball moves in the downward direction. So what is the work done here? It is the positive work done because the ball is moving in the direction of gravitational force. So the work done is positive. Then what happens here? The potential energy decreases and it changes into the kinetic energy. So what is the total work done in this cyclic process? That is in the upward direction the work done is negative, and in the downward direction the work done is positive. So what is the work done? Total work done in moving a particle in this closed path, that is equal to 0. So also we can say that gravitational force is a conservative force because the net work done by the gravitational force on the ball during this closed path is equal to 0. So we can say that gravitational force is a conservative force. Clear? Conservation of mechanical energy in a freely falling body. So mechanical energy means sum of the kinetic energy and potential energy. That is the total mechanical energy of a body, sum of the kinetic energy and potential energy. So here we can see how the mechanical energy is conserved in a freely falling body. So here we are considering a body of mass m lying at position A from a height h from the ground. So when the body falls freely, how can we prove that mechanical energy is conserved? So we can find out the kinetic energy and potential energy at various positions of the object during its free fall, that is position A, position B and position C. So here in practically we can understand, we can see that the body is at a height h from the ground. So it has the maximum potential energy. When the body falls freely, its potential energy decreases and kinetic energy increases. When it reaches the ground, potential energy becomes 0 and kinetic energy becomes maximum. So we can say that the energy is conserved. So we can prove this with this example. Okay, so we can consider at position A. Okay, first we can write at position A. Okay, at position A, what is the kinetic energy? At position A, velocity is 0. That is, we are assuming that the body is at rest. So what is the kinetic energy of the body? Kinetic energy equal to half mv square, where v is 0. So we can write kinetic energy 0. Then what is the potential energy at A? Potential energy is equal to mgh. Okay, that is the body is at a height h from the ground. So potential energy that is equal to mgh. Then what is the total mechanical energy? That total mechanical energy we can represent it as EA. So what is the total mechanical energy? Kinetic energy plus potential energy, that is equal to mgh. Clear? So at the position, at the highest position from the ground, at a height h from the ground, kinetic energy is 0, potential energy is maximum. So total mechanical energy is equal to mgh. Then we consider the point B, at point B, okay, at B. Okay, we can write at B. So at B what happens? The body falls freely and it travels through a distance x from the point A. Okay, it travels through a distance x and the velocity is v. Okay, so according to the equation of motion v square minus u square equal to 2as, we can write what is the final velocity? V square. Okay, v square minus u square. What is the u here? That is equal to 0. Okay, 0 square equal to, what is the acceleration due to gravity? G. Okay, that is 2g. V square minus u square equal to 2g. Yes, so we can write 2g into, what is the distance moved? X. Okay, that is v square minus u square equal to 2g. Yes, or 2as. Then from here we can write v square equal to 2gx. So we got the velocity v square. Then we can write the kinetic energy at B and potential energy. So kinetic energy at B, that is equal to half m v square, that is equal to half into m into 2gx. V square is 2gx. So what is the answer here? That is equal to mgx. Then similarly we can write the potential energy UB. Okay, what is the potential energy? mg, and what is the height here? That is total height h, then minus this distance h minus x. So we can write mg into h minus x. Okay, then we can write the total mechanical energy. Okay, total mechanical energy at B, that is equal to kinetic energy plus potential energy. So what is the kinetic energy? mgx, then plus what is the potential energy? mg into h minus x. So here mgx and minus mgx will cancel. So what is remaining here? That is equal to mgh. So here also total mechanical energy is mgh. Clear? Then similarly at C. Okay, then at C. So at C the body travels and reaches the position C. Okay, so we can consider this motion from A to C. Okay, the body moves from A and it finally reaches the ground C, and then its velocity, we can write its velocity as v dash. Okay, v dash. So here also we can apply the equation of motion. V square minus u square equal to 2as. So what is the final velocity here? That is the v dash square. Okay, v dash square, then minus what is the initial velocity traveling from the point A. Okay, so 0 square, v dash square minus 0 square equal to 2g, and to move through a distance h. So we can write 2gh. Clear? Therefore, v dash square equal to 2gh. Understand? Similarly, then the first two cases, so we can, same as the first two cases, we can find out the kinetic energy at C. That is equal to half into m into v dash square. That is equal to half into m into 2gh. So that is mgh. Okay. Okay, that is kinetic energy mgh. Similarly, potential energy at C. What is the potential energy here? That is mg into, so the body reaches the point C. So what is the height? It is equal to 0. So into 0. So that is equal to 0. Then total mechanical energy at C, that is kinetic energy at C plus potential energy at C, that is equal to mgh plus 0, that is mgh. Clear? So when you observe this one, you can find out that in the first case, the kinetic energy at point A, kinetic energy is 0. Then at point B, then kinetic energy increases. Then at point C, kinetic energy is maximum. Okay. Then what happens to the potential energy? Potential energy is mgh maximum. Then potential energy decreases mg into h minus x. Then potential energy becomes 0 at C. Then what happens? What is the total mechanical energy? In all the cases, total mechanical energy equal to constant. Okay. So we can say that the energy, total mechanical energy is conserved during the freely falling body. Clear? So here when the body falls freely, first the potential energy decreases and kinetic energy increases. So total mechanical energy remains constant at all points. That means total mechanical energy is conserved during a freely falling body. Clear? We can plot kinetic energy and potential energy in a graph. Okay, so here when you look at this graph, you can understand that when height increases, okay, when initially the height is 0, then what is here? Potential energy is 0. Then this is the graph for the potential energy and this is the graph for the kinetic energy. So when the height h equal to 0, this is the origin, okay, 0, potential energy is 0, kinetic energy maximum. Then when the height increases, then what happen? Potential energy becomes maximum, kinetic energy is 0. So what is the total energy? It should be a constant. Okay, so the graph of the total energy is that is a straight line parallel to the height axis or x-axis. So this is the graphical representation of potential energy. When the height is 0, potential energy is 0. When the height increases, potential energy increases. So at the same time, what is kinetic energy? Potential energy is 0, kinetic energy is maximum. Then potential energy is maximum, kinetic energy is 0. Then what is the total energy? Total energy is a constant. So it is a straight line parallel to this x-axis. So this is the energy, okay, energy diagram, potential energy and kinetic energy during the free fall of a body. Clear?